Okay, good morning, good afternoon, everybody. I'm Brian Buffett. I manage the SDMX IO program at the BIS. I'm here with a colleague of mine, Douglas. I'll let him introduce himself in a few minutes. So just a couple of housekeeping details. The webinar is 60 minutes. It's going to be recorded and then published on SDMX IO afterwards. There'll be a Q&A session at the end, so you can post your questions either in the chat or raise your hand. And with that, I'm going to hand it over to Doug to get us started. Thanks.
Great. Thank you, Brian. And thank you, everyone, for attending. It's such an honor for me to be able to speak to all of you about how I personally use SDMX and how I think it can be of use to many of you as well. And I'm looking forward to the interactions we're going to be having. Let me start sharing my screen here because I have some slides at the beginning, and then I want to go to a live demo. Just to set expectations, this is going to be kind of an informal presentation in a way, especially the live demo part. So bear with me if there's any kind of road bumps or anything. But what I want to talk to you about today is how SDMX is actually such a fundamental part of much of my work in machine learning and the data science work as well, and in particular about how SDMX is one of the building blocks of the Gingado library, which is an open source library that is focused on building tools for use of machine learning algorithms in economics and finance. So I know some of you many of you are familiar with SDMX, but some of you might not be. So before really kicking off, how we get to this, I want to make sure we're all on the same page with respect to the main concepts, and also from the perspective of a pure data user. So I'm not a statistician. I'm not involved in the process of compiling or disseminating statistics. I'm more involved in the process of making use of it. So even if you are familiar with SDMX, it's probably because you are involved in one of these more traditional functions. So perhaps this perspective I'll bring today will also be new to you. And then I'll also kind of mention how this is one of the key components of gingado. And then we can talk a little bit about why SDMX is actually a very good tool for many machine learning applications in economics and finance, and in particular, what are the things that SDMX bring to a data user. And then we're going to have, we can have some use cases here. I included some kind of very general use cases. We can go over them, or after I present it for like an end-to-end product, we can even, if we have time, we can even delve into some uncharted territory and try to do something completely new if you want. Again, no guarantee that it will flow and work within time, but just so people can understand in practice how things work out. And then this recording, but also the code is all publicly available, all in the spirit of just being open source and transparent. Okay, so what is SDMX? For many of you, I don't need to repeat that, but for some, it might be good to have this introduction. So it's a statistical data and metadata exchange kind of a protocol or standard. And the way I like one definition or one way to describe it is it's an integrated approach to help with the process of exchanging, reporting, and disseminating statistical data and its metadata. And it's actually, it's so fundamental, so important that it's actually an ISO standard. Just as they have ISO standards for many things, also for data metadata exchange. And in fact, there's quite a bunch of heavyweight institutions behind it, including the BIS, but also many others as well. And what I found interesting as I was preparing for this presentation, that it is recorded by the United Nations as one of the direct contributions to the Sustainable Development Goals. So, yay. We, in particular, in the part about industry, innovation, and infrastructure. And in fact, there's a whole ecosystem of applications that use SDMX and that help users use SDMX. Gingado is one of them, but it's really kind of a broad compilation. You can check all of that out in the SDMX experimentation.io webpage. And, there's throughout all the whole process from, modeling the data, let's say, what are the columns, what are the dimensions that describe your data or that give more information to it and its metadata, to help data collection, the actual production of statistics, dissemination, and then in the case of gingado, how you can go and take all this data that has benefited from SDMX and its open source ecosystems to put to use to answer real life questions. If you want to forecast, if you work in a central bank, you want to, let's say, have a short-term forecast of the exchange rate of your country, or if you're doing economic research that involves machine learning some way. It doesn't need to be machine learning, by the way. It can just be also traditional econometrics. I'll show machine learning here because I think it's a very interesting application to use high-quality data with these powerful techniques in a reproducible way. Okay, so some concepts that will be important to bear in mind. One, we have what we call this data structure definition. And I'm speaking here in the Brian's control. So if I'm not being exactly, complying with the formal definition, please jump in. But this is at least the way I like to think about these concepts in my mind, at least as a data user. So the first one is a data structure definition. And it's essentially kind of a type of metadata that will describe every data point that you have in a data set. So for example, if we're talking about a data set about exchange rates, then one of them would be the currency pairs. So currency 1 and currency 2. The other one would be if it's the actual monetary amount or the growth rate, or all of the things that when you read them will help describe and really identify very precisely what data you're talking about. And these can differ into dimensions that are the actual things that define your data, but also measures, meaning kind of the magnitude that the data is valued in. I mean, is it dollars? Is it thousands of dollars, for example? Is it percent of GDP in the case of some other variables? And you also have attributes, which they don't exactly identify your data, but they give some meaningful information like, is this data point subject to, let's say, a structural break? For example, maybe, let's say we're talking about exchange rate pairs, and then suppose one country, like for example, Croatia, they joined the euro. So the exchange rate of the Croatian currency against the dollar would be first the Croatian currency and then the euro, and then it would have an attribute saying, oh, there was a structural break here. And then you have code lists. So code lists are very interesting because they are essentially all of the permissible values that a dimension can have. So in the case of exchange rates, a code list would be all of the possible currencies, or it could be all of the possible frequencies that a data can take up. So code lists will be, really kind of a very comprehensive list. Of course, not all of them might be available in each data set, but at least what are the permissible currencies, frequencies, types of derivatives or derivative statistics. So those are the way you help describe your dimensions. And then data flow, the way I see it, is actually it's the actual data set combined with all of this metadata in terms of what are the dimensions, and for each dimension have the code list. And then a data flow is kind of a very neat package that a data provider like the BIS or like the UN, the World Bank, and many others, they can make available to the wider public or between themselves as they're kind of exchanging statistics as well. Okay, so that is a lot of definition, and I'm sure all of you get how important this is when we're talking about data and how helpful this is in the process of data management and statistical production. But then it can also be helpful for us in the other side of the fence that are using actually kind of taking this data and using for manifold use cases. One of the reasons why SDMX is from the start, from the very first version of gingado, the open source library I'll describe in a second, why SDMX has been a building block is because, first of all, it helps us get data in an easy way from trusted sources. So if you have a machine learning application, you can leverage SDMX to go and fetch relatively easily data from, known providers from statistical agencies or other official bodies like the European Statistical Agency or the Australian Statistic Bureau, or many others or the International Labor Organization. So others that are official sources that we can just trust the data that comes from them. And also because SDMX helps us kind of describe the data, it also helps us find relevant data. So if, for example, if you're doing an application again about exchange rates, and then suppose you want to predict it, and then you say, well, maybe one interesting predictor would be, let's say, central bank policy rates. Because of the way those data flows are defined and all of this metadata, you can more easily find relevant data for you. And again, because you have all the time series, it's easy to merge with your own data. And this is one of the things that gingado does, and I'm going to show you today. And then another thing is that, it's all about quality control. So if you have a research piece, or if you have an internal, say you work in a central bank or another, any other type of institution, and you have an ongoing product, let's say a stress test or an analysis you present to the board every few weeks or something like this, then having a programmatic way to download the data will make sure you know exactly what you're downloading, and that you can then reproduce over and over again, and you can debug, and it's easy to audit, it's easy to reproduce, and you can also scale that more, because with SDMX definitions, it can help you find other relevant data to make your let's say, to feed more data into your model that is potentially relevant. Because you don't just want to put all of the available data in the world to a machine learning model. It's going to be a lot of noise. But if you have some way to help you find relevant data for your application, this can actually improve your machine learning models. Of course, nothing in life, is complete and perfect. So, for example, some of the things in my wish list and my Dear Santa list and that I hope, kind of just this open source development of SDMX can eventually contribute also from our perspective as data users, include things, for example, like, the ability to just go and list all of the available data from, kind of like multiple sources at the same time. I try to do some of this with gingado, but it's not yet perfect, because it's still a bit hard to go and filter and say, give me all relevant data about derivatives about this country, regardless of the data provider, of the data flow. So this is still, we still have some ways to go, but we're also not that far. And also another thing, if I can, think about the future, would be if we could have an open source model that can help us in natural language find the statistical data using SDMX. So this would be pretty cool. I know there are some applications out there, but having an open source model, at least to my knowledge, doesn't exist yet. Maybe, who knows, someone here in the crowd will do this. Maybe even if you do this, let me know. We can even post this in gingado. But it will be very interesting to say, well, I want data about central bank monetary policy rates, and it would already find for such and such country. It would already give us a query that we can then go and use. So again, this is wish list, but let me now go back to what we have today. So gingado, as I said, from the very first day, it started out as a library that tries to use SDMX and other tools to help machine learning workflows in economics and finance. In machine learning is actually, there's pretty well-developed workflows out there for general applications like computer vision or like language. But when we talk about economics, we have some particular things that are not always center of mind for, general machine learning developers. So over time, this is how gingado started, as a compilation of tools to get data, and then try out models in a way that makes economic sense, and then to document these models. Because they, in my view, they require some steps that are very specific to our own universe here. So this is the genesis story of gingado, and the first part specifically, gathering data, and then trying out models where you might or you might not use more data than you initially had. This is where SDMX can contribute a lot, actually. Okay, so just a couple of slides before we go to actual live demos and then Q&A. Gingado is fully open source, it's free and open source, and it's made also from the get-go to be compatible with widely used kind of AI machine learning libraries like scikit-learn, pandas, NumPy. So if you already know how to work with these, and if you work with Python, you probably already work with these anyway. The API should feel familiar. This is the goal. Also in the SDMX applications. Again, because it's really about facilitating these use cases and just something to bear in mind when as Gingado evolves, I know we have some kind of these key design principles in terms of flexibility. The library you should work well just out of the box, but if you want to dive in, it also allows you to. It should also be compatible again with these kind of widely used libraries. And also in terms of responsibility, we hope to also promote as part of the workflow the process of documenting what you did. And SDMX, of course, by helping making things reproducible and more transparent and more precise, they should also help with respect to this as well. Okay. Having said all of this, Gingado is still a work in progress. So for those of you that are familiar with the software versioning, this is still version 0.2.5. And the first 0 means that, we might make some big design changes as of yet, but it is already production ready. In fact, I have already used this in one working paper, and I'm using another paper that should come out soon. So it is functional. You can just download and use it now, but if you use it on a rolling basis or some product you have, this means that when we move to 1.0, there might be a few changes, but not that everything will be well documented. Just as Gingado currently is, yes. All of your comments, questions, suggestions, criticisms will be very helpful to take this work forward, both Gingado itself, but also how we use SDMX as data users. And in fact, actually, even working towards preparing this presentation, I noted that one or two things that were within reach that I thought would be helpful for users that were not yet in Gingado were missing. So I already started coding them. So you will see we will use a temporary version, but this will be incorporated in the upcoming version of Gingado anytime soon. And of course, if you are yourself a coder or would like to delve in, feel free to click the link here to our repository where you can contribute code. You can let us know any bug you might find. And if you're really kind of a power user of SDMX with machine learning, you want to kind of dive even deeper, maybe in addition to Gingado, we can also go to the original library that we use as a backend, which is called SDMX1. SDMX1 is a great library. Gingado uses this in a way that makes it much easier to use for relatively normal use cases. But if your use case is very complex, or if you want to have a very detailed vision of what's going on behind the scenes in a step-by-step way, then maybe going to SDMX1 is the way to go for you. We will not cover this today, but I just wanted to raise it as well, and kudos to the people contributing to that. Okay, any questions before we go to a live demo? And Brian, please help me monitor here the chat and the hands raised. Okay, so since there are no questions here, then let me go to the live demo part. Okay, so I created a Google Colab. The only reason I already have some code here, and this is the only code here, is because, as I said, we will be using this temporary version of Gingado, just because there is one new function that is not yet incorporated in the mainstream Gingado. Okay, but if you want to use the mainstream Gingado, you can follow all of the examples or one function which will come out soon. So if you are just starting out with a Google Colab or something like this, and you never used gingado before, it's very easy. You can just do a pip install gingado, and that's it. And then it will get from pip all of the dependencies. So very, very easy to install. As you can see, already installed here. But as I said, we will be using this version with a very specific function here. So let me actually do this. This live coding is actually inspired, or let's say it's heavily based on existing examples in the gingado documentation. So if you want to follow along, or if you want to later on, if you want to read in more detail or see, let's say, more mainstream application, you can just here. And then there's examples. So today we're going to go to the forecasting FX rates, and then if we have time, effects of labor reform. Okay. And then we have a step-by-step. And if you have any questions, all of the documentation is here. For example, all of the functions we'll be using, we can even leave this open here. We have, documentation with examples, with code that you can copy and paste. Yeah, you can even see the output. So again, the purpose is to be transparent. Okay, so I think now this version of gingado is already installed. Let me run it again just to be sure. And let's hit the road. Okay. So as I said, what we do now is we're going to be using gingado to kind of forecast these exchange rates. Now, the first thing we do is, of course, we need to import. And the way we do this is part of a module called utils for utilities. So from gingado utils, we're going to be importing the list of data flows. Let's go step by step. Okay, and now let's attribute here. So what this function does is it looks at all of the sources that we have, and then it creates a huge list of all of the data flows that gingado knows how to download from SDMX. So if you're just starting, this is usually a good first step. Now, one of the things is that because it's probing a few dozen statistical providers and asking it some data about all of the data flows, and then it validates all of this data, and the first time you run it, it takes a bit of a while. So that's why I left it running while I'm speaking. But once you do this, you essentially have, let's say, a master list of all of the sources, BIS, ECB, UN, etc. And for each source, you have a data flow. And data flows, they have a code or a name, and they have a real natural language description. So, for example, they might be called WSXRU, and then there's a description say it's the exchange rate against the dollar, for example. Okay, so it's still running a little bit here. In the meantime, of course, if there's any, by the way, if there's any questions, it's hard for me to monitor. So just open up your mic and yeah, let me know so it keeps it on. Can you all hear me?
Yes, Doug, we hear you fine.
Okay, great. Okay, yeah, because I noticed someone wrote in the chat that they can hear me, but okay. In the meantime, let me show you here a little bit more of the documentation. So we have for each function, you have kind of the output, and then some of the things that you can do with it, like some examples here. You also have documentation of all the parameters that you can use. So again, if you have any questions, you can always refer to the documentation. Okay, so it should be completed by now. Usually takes only a few minutes. In the meantime, just look here if there's I guess sorry, there's Yeah, I want to show there's a quick way kind of to look at, to find with text some data that you might be interested in, but we need, I just found it here, but we need to wait for it to load. And as I said, it takes a while, but this is just the first time that. Is there someone in the chat?
Oh, there's
Okay,
just
so
a few
now
people
it's
having
analyzed.
difficulty with sound and with the screen, but it's on their side.
Okay, thanks. Okay, so Giuseppe, I see you have your hand raised, but I cannot hear you.
Okay, now I can. Okay, thank you very much. So, Doug, a very simple question. Here, we see that we can load many data sets in SDMX format. But my question is, what about having simple CSV files or other ASCII format? Do you have examples also in here?
Yeah, no, thanks. Thank you, Giuseppe. No, that's a very good question. So there are cases when you have data points that, you know, they come in a CSV format or some Excel format or in a SQL database, and you need to merge them with, and you could consider or need to merge them with data that you get through SDMX. There's a way to do this, but using SDMX on CSV data, etc., this is not something that Gingado does. Gingado, what it tries to do is, because we already have tools for this, if I recall correctly, combining FMR with .stat suite, for example. Again, I'm a bit out of my element here, but my recollection that it would help to organize data according to a data model. Here it's just about getting data from the internet, from these data providers, and then just using it. Okay, so after 5 minutes, we have a list of data flows. So skip all this. So just to show you what we are talking about. So here we have, again, the first key here is the data provider. And then here we have the name of each data flow, and here what the data flow is actually about. So for example, I work in the BIS, so let's look at what we offer. And it's those data flows here. So we have, for example, a monetary policy rate data flow, central bank total assets, you know, various kind of medium payments and market infrastructure data sets, credit to GDP gaps. If we were interested, let's say, in what ESTAT offers, so the European Statistical Agency, then actually more than 7,700 data flows, including the gross weight of goods handled in all ports, for example. So again, very specific. Now, if we want to find something particular, because it's organized this way, we can go and say, well, give me all of the data flows that contains the word, for example, let's say exchange rate. And then you have here the BIS has data flows about effective and, you know, US dollar exchange rates. ECB has one as well, ESTAT, the International Labor Organization, International Monetary Fund, and so on and so forth. So there's a few use cases that we can do. Now let's focus here, for example, on this one here, the case of the BIS. So now that we know the source and we know the name of the data flow we're after, we can now call another function called load SDMX data. Okay, so it's already loaded. So what we can do now is we can say, well, now that we know all of that information, we can essentially help fill 3 parameters here. We can say I want data from the BIS and the data set called XRU. I want its parameters, and we'll get to later how we know which parameters to ask for. For example, I know from this prior example that well, first it has a frequency, which is daily in this case. And then again, there's a new way that I just incorporated into how we can see all the possible values. And then we have a currency. Well, it's kind of cool that the AI already tries to fill in, although I don't know if the later one is correct. So let's say I want the Brazilian exchange rate against the dollar and the Swiss one. And yeah, so that's it. And then there's another parameter called keys. And keys essentially is just a way to include the date. I only ever use it for dates, but I don't even know if there's other types of parameters. But usually the way you define the data that you want from a particular data set is here in the params argument. And the keys essentially you can think of it as just limiting the time period. So you can have a start. You can also have an ending period if you want. I don't want that, but we could have here kind of a well-constrained period. Okay, so once you do this, this is not source. So what is the argument? The sources. Sorry. Okay, so this is the beauty of live demos. They often don't work. One reason is that for some data providers, they include as part of the data flow, they have, let's say, sub-data flows, one for each frequency. So in the case of the BIS, when I do this, we all we need to do is append an underline D here, and then we're talking about the daily exchange rates, and now it should work. Okay, so okay, well, maybe we can try another one. The frequency, let me just check here. Kind of. Well, now this is what the real life looks like when we're working with data science and machine learning. Let's try another one. Let's try, for example, the DCB one. Okay. So, maybe one of the things I'm doing is precisely I'm not passing the data as it should. So it's a good time to showcase the upcoming new tool called code lists. And what it does is it tells me what are the permissible values, what are the possible values in each dimension, and also what are the dimensions that exist for each particular data flow. So in this case, and this is work in progress. I said not yet in the main version of Gingado, but you can already test it out. So let's say as a beta version. So let's say I'm interested in finding out what's going on in this data set here. Okay, so maybe it's the internet. It's not working. Okay. Of course, I should attribute this to something so I can consult it later. Okay, so I now included this out. So essentially now I have this, the CL here is a dictionary. So dictionary is a collection of keys and then elements, one for each key. You can think of them like, you know, tabs in an Excel file. So we have all of these dimensions here. So we have, for example, the reference area, the type of collection, the decimals, the frequency. So I see here that it's called CL-FREC. So maybe what I should have done here, if I'm using, so going back to the BIS one, maybe this should have been CL-FREC. And let me just see what we get if we do this. Just to see that, you know, there is some data. Let me go to another application and then I'll debug this one. And in the code that I'll be sharing, all of this will be working just as it works in the documentation. You know, there's a note saying millennia ago, people already knew that live demos were already subject to a lot of pressure, especially close to Halloween. So bear that in mind. Okay, so let's try and look at another example. And also because of time, I can show you how to use this with a machine learning application that I use in a paper. So here, let me read this one. Changing gears now a little bit. Now, what I want to show you is an application where I studied labor productivity. Yeah, sure.
Before switching over, Giuseppe has his hand up.
Sure, yeah, go ahead. I'm not checking the chat or the hand raise, so feel free to jump in.
Thanks, Brian. But listen, just one question. In the previous screenshot was written that the kind of data that you were asking for didn't have that frequency and that starting point. Can you try to, instead of asking for daily frequency, say quarterly or yearly?
Yeah, sure. Although I have worked with that particular data,
you did.
I'm a bit puzzled, but
sorry, I didn't.
No, but that's a good point. So let's try that now. Yeah. So let's go back here to the BIS and then dollar exchange rates. And then in the parameters here. Ah, no, sorry. I know what happened actually. I switched the parameter names. So the keys, yeah, so the keys should be, so that's why. So let me now go back to, okay, so I'm very glad that you suggested this, Giuseppe, because then this made me realize I actually mixed up the parameters.
Okay.
Okay, so let's see what the code list that we have here. Okay, so I think that will work. So for example, in the CL, let's see if I want to see what are the possible frequencies of any data set, then I can just consult this code list for this particular one. It does not mean that this particular data set has all of these frequencies. It just means that if you are going to filter by some frequency and hope to get data out, it should be one of those key years. So in this case, for example, I know that this data is daily. There's a way you can consult all of the permissible for each data set, but there's a bit of a more detailed application. So in this case here, what I want to do now is frequency daily, and then params is start period. So thank you everyone for bearing with me. Now it should work. Okay, so it's querying the data set. Thank you again for making me revisit this example with this coding wonder.
Oh, I see.
And you will note that when the data comes out, because we want the user to always know what's going on, it's going to be essentially a table where the rows are different dates and the columns are different combinations of the data. So this is a simple, actually, I didn't include here the currency. So it's probably creating all of the possible currencies. Actually, let me stop here so we can move faster. Yeah, because otherwise it just takes a long time to, the currencies. Again, let's see, Brazilian, Swiss, and Canadian. So we have 3 examples. But then the point is, you want to know all the time what each column refers to. So the column names, they will be convoluted, as you will see now. You can see here we have BIS, double underline, the name of the data flow, double underline, BR, double underline, BRL, double underline A. So what this means is, it essentially all the column names, they combine. So you always know what's going on. They combine the data flow, the source, the data flow, and a number of other defining characteristics. Now, we don't always want that. For this simple application here, we don't need it. So for example, let me just now finally show you some data. Okay, for those of you that are not familiar, in blue we have the Brazilian exchange rate against the dollar. In green we have the Canadian dollar against the US dollar. And in orange we have the Swiss franc also against it. Okay, so but as I said, we don't always want this. So let me simplify the column names here. Simple one. Okay, so it's not taking my. Let's see if this works. Okay, actually I lost a column. Sorry for that. No, let's not bother with the column names now. We're actually only 15 minutes to go. Let's do some machine learning finally. What I wanted to show you now is a way that you can then, so we use SDMX to get this data after, kind of some roadblocks that you have saw. But now let's say, so suppose this is all of the data that you have originally. And you think that, maybe there's some other data sets that might be useful for predicting, for example, currency changes. And then also here, SDMX can help you find relevant data that speaks directly to your data set. So let me see. Okay, let me have the original column names. Now the first thing we do is let's not do a percent change, because if we're forecasting the currency, we want to forecast the currency change on a day-by-day basis. And then we take out the dates where the first date where we don't have a prior date to the difference against. So what this gives us is a data set like this. So every day we have, changes around 0. Again, the same colors for each currency. And now we want to predict those spikes, or we want to predict these movements. And this is incredibly hard. And this is not exactly how the finance literature does this, but I just wanted to kind of showcase with a simple and hopefully intuitive example. of how we can do some of this. Okay, so let's now suppose we want to forecast that we can always, regress them against itself, and it's a very actually powerful technique for FX reads. We can also try out new data sets. One way that Gingado allows you to do this is by calling the augmentation method. It has this called augment SDMX kind of a functionality where what it does is it takes your data and it looks at the dates. And then once you provided some specific data flow, or if you just say, give me all of the data flows for a particular source, and then we'll find all of the relevant data that are related to the same date as your own data. So essentially, it will take, let's say in this case, your 3-column table, and you can append hundreds of other data points with a few lines of code and controlling what's going on there, because you know exactly what was the source, what was the data flow, and then you can even filter out because the column name contains all of the relevant information. So let's show this in practice. So again, we have, this is our data set, DFFX. So data frame with the FX rates, where we have the daily change in exchange rate against the dollar for Brazilian real, Swiss franc, and Canadian dollar. Suppose we want to add more information, and we only care about that the dates match for each day. So one way to do this is we can then come here, since we already imported the augment SDMX, we can, for example, let's say I want to use the ECB. They have, for example, a very useful daily indicator of systemic risk that is based on financial market metrics. Since, as we're looking here, we can see that, volatility or the range of these changes, it's shrinking kind of in normal times, but then it bumps up in more stress times, like, around the 2008 crisis, or, around, for example, the Swiss cap against the euro, or even around COVID. So because these things change, perhaps the systemic risk indicator could also help predict exchange rates, for example. And again, I'm not being super formal on the finance side. I just want to illustrate with an intuitive case here. So let's do this then. The name of that data code is, for example, let's now look into this. Systemic. Okay, so the source is the ECB. The data flow is called CISS, and it's the composite indicator of systemic stress. So let's use it now. Augmented data frame will be augment SDMX. And then it has, you can see here, if you hover your mouse around it, because it's well documented, it opens up. And then essentially one of the argument is this sources. And then the sources argument, we can say, well, again, give it the ECB data flow called the CISS. And then we do something called fit transform. So those of you that might be familiar with the widely used library scikit-learn, you have, when we call fit transform, what it does, it looks at your original data and it learns what it needs to learn. In this case, what are the relevant dates? And then, of course, it combines with the information you inputted as a user. In this case, whatever you wanted. In this case, composite indicator systemic stress. And the transform part means that whatever comes out of it will be a transformed version of your original data based on, again, the dates that it has learned and whatever input you have chosen to include here. So this has already been done. So let's now inspect augment SDMX. Those are the original columns, as you might recall. So they came from the BIS. Data flow is called XRU. And it's about the Brazilian currency, Swiss currency, Canadian currency. But now we have DCB CISS data flow. And you can see here that we have this for multiple countries. So we have probably for Austria, and then there's a number of other definitions that if we had time, we could go into more detail. but then essentially we now have a bunch of other data points. Why this is important? There's a very interesting paper in Econometrica called "The Illusion of Sparsity." What they show is that in most economic and finance settings, you essentially have one or two routes. You can either have machine learning models that will handpick only the most significant variables of all of these, in this case, 25 columns. They will only pick the few ones that are most informative and use this in a model. And this is one class of models. Another class will look at everything at the same time. Everything might not matter at the same time, but it will take, cast a wide net and it will then learn where to focus its attention, but without focusing entirely on only a few predictors. What this means in practice, and what they found is that the latter type of model works better. You have less model risk because in many cases, we don't really know what's going on behind the scenes. So the more informative data you send it, you let the model choose, tends to work better than us choosing or the model only picking a few variables. So in this case, I very easily added here 25 columns, but let's expand this. Let's say in addition to DCB, I also think that for FX rate prediction, I think the central bank monetary policy rate would be informative as well. So let's see here. What are the data flows containing policy? The BIS has a data flow containing the central bank policy rate. Again, everything else includes a bunch of other things that are not necessarily central bank policy. So let's include this here again with the daily frequency, and let's see now. And then of course, because we have dozens of central banks, then this table here will go from the original 3. Instead of going to 25 columns that incorporate only the ECB's various breakdowns of the composite indicator of systemic stress, we're also going to be having, in addition to this, the BIS's data flows, so one central bank policy for each country. Okay, which is being downloaded now, as you can see here. And then once this is done, that your range of informative data, and again trusted data, because all of this comes from trusted sources and it's fully reproducible. Your set of data, high quality data, is much larger. This generally helps machine learning models to make better, let's say, models with a better forecasting ability, provided that they can find signal in this space. Now, of course, while we're running, I just wanted to mention that there's one way to test, and again, it shows off the value of let's see now, instead of 25 columns, let's see how many columns we have. So now we have 64 columns. That includes our original 3 ones, the BIS exchange rate, ECB's stress indicator, and then if we scroll to the right, we see a bunch of BIS central bank policy rate for Thailand, for Turkey, for the US, for Sweden, and then let's see, if we remove all of the dates with missing data points, then we have in this case from 2003 up until essentially last week, we have 4,600 data points that you can then try and forecast. We won't have time today, but all of the code, I'll leave an end-to-end code where you can do this and change some parameters and tweak around. What I wanted to show in the last minutes, if there's not any questions, is that another thing where it pays off to be compatible with widely used techniques is that it can help us to offer machine learning model the possibility for the model to decide, is it better to try and forecast with only your original variables or also with this extended variable? The way we do this is with the called the pipeline. So let me show you documentation, for example, for reference, documentation. in the part about compatibility, what it shows essentially is, as you see, the same object, augment SDMX, fit transform. We can also match that with what we call pipeline. So let me copy this code here. Just for agility. So I am importing from scikit-learn this object called pipeline. Pipeline, what it does is, well, it creates a workflow of data from your original data all the way until when it's being fed to a machine learning model. And the reason why it's important is that we can then use a code here, which I'll show you later what it is. We can then create a pipeline of which includes this augmentation. So essentially, what it does is it's now saying the model, you will run the model just with the original data, and you'll run the same model with this extra data set that it obtains directly from SDMX. And behind the scenes, that it makes sure that it's always talking about the exact same dates. So you don't have to worry about that. And then the model itself will tell you what is the best alternative. Is the best alternative to augment your data set? Then it'll tell you. And then if it's not, it'll also tell you that, if you just keep original data, then it will tend to perform better. Sometimes this happens. But again, just wanted to show you that we have an end-to-end example here that we won't have time now to go through. I wanted to leave the last minutes for questions. But yeah, then it can essentially, you can train a model with no augmentation or with augmentation, and then you have the result, whatever works best. So this is what we have time for today. You can find more information in the Gingado webpage, as the library itself is being constantly updated to include new things, new documentation. We are looking forward to including in the coming months new examples as well. So please let me know if you have any questions or comments or feedback, and I'd be happy to tackle. Thank you very much.
Thanks, Doug. At this point, there's no questions in the chat, so we do have 2 minutes left. If anybody does.
Okay, so
Go ahead.
So if I have 2 minutes, let's try and do this pipeline thing here. So, yeah, for agility, I'm just copying the code from the documentation, but as you're seeing, this is a completely new environment, so it should work here. Okay, now I want to use the ECB's CISS as a complementer, and then try to forecast. Okay, so, and then we can go here. Okay, 1 minute perhaps. We'll have time, but then essentially we now have a. Okay, didn't pull the text here. Yeah, so then if we had the data, we could just, for example, grid fit, let's say our X data is the, say, augmented, for example, the FFX, and then the, so up until the, for example, the last one, and here is just from the first one. I don't know if it's going to work, and super simple example, but just wanted to show that you will try both with the augmentation and without the augmentation. As you can see here, it's now, as part of the fitting process, is now querying the ECB's data. Okay, and,
two questions
yes,
posted
sir.
from Danielle.
Can you read aloud, please? I cannot see the chat here.
Does your library download data from different sources? And if data source requires authentication, does it take care of it?
So it uses the SDMX1 as a library as a backend. Usually, whenever I run this, both in a central bank internal environment and also Google Colab, I never had any problem with the data itself, again, because it comes from trusted sources. But that's a good question. If I were you, I would try out and see what happens. Okay, so should be finishing now because we have 4 fits. We have one of them with no augmentation. Then we have 2 of them with augmentation, and the second one is finishing. And as you can see here, if you're just fitting with your original data, then it takes 1 second. But if you're fitting with more data, then it takes 30 seconds. Again, speaking to the quantity of data that we have. So if you, for those of you that are able to hang out just another minute, then we'll show, just our curiosity, which one would tend to work best here. Okay, so now I can see Daniela's question here. Yeah, so the data sources, they can be quite large, indeed. So usually the backend stores the data in memory. But if your data is so large that it will kind of crowd out your whole memory, then one way you can do this, I would recommend going to the SDMX1 library. As I said, it's easier for more customizable examples. You will not have as easy of a life as when you use Gingado, because Gingado tries and simplify many things, but what it buys you is the ability to customize and then say, oh, I want to store this large data in a SQLite, for example, file. So you can do this if you go to the original SDMX1 library. I hope I answered your question. Yeah, so good question, Andreas. So Andreas asked about, does it work also with more granular data, like internal data only available to supervisors? So it doesn't work directly with this data because it tries to look out for publicly available data that use an SDMX type of API to make the data available. But I mean, the Gingado's code is open source, so it shouldn't be hard. And in fact, if you already have a data that is modeled after SDMX, then yeah, passing, even if it's internal, passing this through Gingado for machine learning should not be hard. And in fact, so the code is available, it should be easy to adjust. Okay, so now we have here the grid. Let's now just out of curiosity consult the best estimator. Now I'm curious. Okay, so the best estimator, according to a consolidation in a super informal way, is actually with the ECB composite index. And again, you would only know this by passing here. You can also try various others. We won't have time to do today, but then again, you can come here and just say, sorry, I want all of the data flows from the BIS and the ECB CIS. It will take more time, but it will let you know exactly what works best for your particular application. Okay, so we are over time. I would like to thank Brian again for the opportunity and the whole SDMX.io team. And I would like to thank all of you as well for your attention and your patience also with the coding issue, and also for your interest. And I'm looking forward to continue this interaction with you. So thank you all very much.
Thanks a lot, Doug. Thanks everybody for participating. The recording should be online within 2 weeks. And again, thanks and have a great day. And look forward to more from Gingado in the future, Doug.
Great, and I'm looking forward to continue this conversation. And keep tabs on Gingado for all of you interested in using it with SDMX or the machine learning part or both together, because we are continuing to evolve it, and we should have new exciting developments coming soon, including on the SDMX part. Thank you all.